we will talk about the specific gravity and absorption of coarse aggregate test. This video will tackle the following topics: background, specific gravity use, aggregate absorption use, testing objective, scope, and importance. First, let us know the definition of specific gravity. Specific gravity is the measure of material's density or mass per unit volume as compared to the density of water at 73.4 Fahrenheit or 23 degrees Celsius. Therefore, by definition, water at temperature of 73.4 Fahrenheit or 23 degrees Celsius has a specific gravity of 1. The specific gravity of coarse aggregate is the weight of aggregate dried to constant weight in an oven at 100 degrees Celsius divided by its absolute volume, including the natural void within the aggregate particles. So what is the use of specific gravity, especially in the construction? Aggregate specific gravity is used in number of applications, including superbay mix design, deleterious particle identification and separation, and material property change identification. Note that all rocks and stone contain some small amount of void, and the specific gravity is an indirect measure of aggregate porosity. A low specific gravity may indicate high porosity, and therefore it offers poor durability and low strength. So what is the importance of the specific gravity of aggregate? First, the specific gravity of aggregate indirectly measures density. Hence, it is the most essential parameter of strength or quality of aggregate. Higher specific gravity is higher the strength. It is due to the higher specific gravity there would be higher compressive strength of aggregate, and hence it passes to the concrete. The second one is lower specific gravity indicates high porosity. Such aggregates are weaker in comparison to aggregate of higher specific gravity. The third one is it is important in consideration when you deal with lightweight aggregates like hollow blocks. The fourth one is some harmful particles are lighter than the good particles in aggregate. Hence, by tracking the specific gravity of aggregates, one can get to know the change of material or possible contamination in it. And the number 5 is some harmful particles are lighter than the good particles in aggregates. Hence, by tracking the specific gravity of aggregates, one can get to know the change of material or possible contamination in it. Production of aggregate by using the difference in specific harmful gravity, harmful particles can be separated from good by using heavy media liquid like you can see in the pictures. The sixth one is, in the cement concrete, the percentage of void and the solid volume of aggregate can be calculated with the help of the specific gravity. The last one is in concrete technology, specific gravity of aggregate is essential in calculating the compacting factor in connection to the workability of measurements. So those are the importance of specific gravity in construction. So let's move on the absorption. So what is absorption? It is the measure of amount of water that aggregate can absorb into its pore structure. Pores that can absorb water are also referred as water permeable voids. So what is the use of aggregate absorption? Aggregate absorption is increase of mass due to water in the pores of material. Aggregate absorption is useful quality because high values can indicate non-durable aggregate or low-strength aggregate or material. Absorption can indicate the amount of asphalt binder the aggregate can absorb. It is generally desirable to avoid highly absorbative aggregate in hot mix asphalt or HMA. This is because asphalt binder that is absorbed by the aggregate is not available to coat the aggregate particle surface and is therefore available for bonding. Therefore, highly absorbative aggregate require more asphalt binder to develop the same film thickness as less absorbative aggregate, making the resulting hot mix asphalt more expensive. So now that we know the specific gravity and absorption, let us move on to the testing objective of the test. The test of specific gravity and absorption of coarse aggregate aims to determine the quality of the coarse material and its water absorption. This method is limited only for coarse aggregate and is not intended to be used in the lightweight aggregates. It is also observes the proper procedure on how to conduct with respect to Astm C127 or standard test method for relative density or specific gravity and absorption of coarse aggregate. Now that we know those details, let's move on to safety and precautions on the laboratory.
So here are the apparatus required. Sieve number 4 with an opening size of 4.75 mm. Container or mold, water, trowel, clean dry towel, weighing scale with clamp third, digital weighing scale, metal tray, brush, drying oven, and flask basket.
Thank you, Laika, for the informative discussion. And next, the safety and precaution. Number 1. Use hand gloves, safety shoes, and apron at the time of test. Pwede natin sabihin PPE or personal protective equipment na kailangan isuot pag ikaw ay maglalab or magte-testing, etc. Ito ay pang-protekta sa mga di magandang pwede mangyari. Importante ito para preparation sa healthy and safety risk, and nagbibigay din to ng extra protection event of an accident or against the elements. Next, number 2, properly brush sieve number 4 and flask basket so that no soil particles were stuck in them before and after use it. Make sure na walang maiwang dumi or soil particles bago at pagkatapos gamitin. Number 3, to avoid machine in harmful particle, always clean the laboratory hot air oven before and after using it. Etong number 3 na safety precaution is common na lang. When we conduct a laboratory, we need to clean the laboratory equipment like the hot air oven to avoid harmful particles that can cause machine malfunction. Number 4, make sure that the flask basket is properly tiered under the weighing scale. At kailangan laging tama ang pagkakalagay ng flask basket under the weighing scale para maging accurate yung magiging result. Next is number 5. After test, switch off the apparatus and para maiwasan ng mga sunog at iba pang sakuna, i-turn off ang mga apparatus para tipid sa kuryente, then avoid pa sa sunog. Number 6. Before conducting the test, make sure that no one is around 1 meter radius from testing machine. This is the important part pag sisimulan na ang testing ng 1 meter radius from testing machine, kasi baka pag napakalapit nyo, matatamaan kayo sa mata or di sinasadyang accident, so dapat sumunod sa safety precaution. So remember to follow the safety and precaution to have an accurate result on the test and to be safe from accident. Now that you know the safety and precaution during laboratory, here is a video of coarse aggregate specific gravity and absorption testing. Please note the following procedures that showed in video. Thank you.
Welcome to the CTTP training videos. ASTO T85, Specific Gravity and Absorption of Coarse Aggregate. This video outlines the steps to prepare a sample for testing. Obtain a representative field sample. Dry the sample to a constant mass at 230 plus or minus 9 degrees Fahrenheit. Remove the sample from the oven and cool to room temperature. Process the sample over the appropriate sieve, which is typically the number 4 sieve. Discard any aggregate passing the sieve. Ensure that the test sample meets minimum sample size requirements. Wash the sample to remove dust or other coatings from the aggregate. Completely cover the aggregate with water. Allow it to soak for 15 to 19 hours. Please visit our website at cttp.org for other training videos and modules.
AASHTO T85 and ASTM C127 are the standard method of test for determining specific gravity and absorption of coarse aggregate. The purpose of the specific gravity test is to determine the physical properties of the coarse aggregate for concrete mix proportioning. A change in this value will change the amount of coarse aggregate in a given concrete mixture. Absorption is a measurement of water in the aggregate pores. This value is critical to maintaining a consistent water-cement ratio. To perform this test, you will need a 4.75 millimeter or number 4 sieve, a large absorbent cloth, a wire mesh basket with number 6 mesh or finer, a scale. For AASHTO, the scale must conform to classification M231, while for ASTM it must be accurate to 0.5 grams. A water tank, and finally an oven accurate to 110 plus or minus 5 degrees Celsius. We will now review the steps of AASHTO T85 and ASTM C127. Once again, these steps come directly from the ACI Technician's Handbook. Once we've obtained our sample, we want to reduce it to the appropriate testing size based on the maximum size aggregate. We now want to dry sieve our sample, rejecting any material that passes the number 4 sieve and keeping any material which is retained on this sieve. We now want to wash our sample to remove any dust particles that may be coating our aggregate. After thoroughly washing, we want to dry our sample to a constant mass. After drying, we want to soak our sample in room temperature water for 15 to 19 hours. Remember, for ASTM, this is 20 plus or minus 4 hours. We now want to roll our sample in a large absorbent cloth. Be sure to take care to avoid evaporation. When complete, our aggregate should be in the saturated surface dry, or what's commonly referred to as SSD condition. We now want to record the mass of our sample in the SSD condition. For AASHTO, we'll record to the nearest 1 gram or 0.1% of the sample size, while for ASTM, we will record to the nearest 0.5 grams or 0.05% of the sample. We now want to put our sample in the wire basket and immediately submerge the sample and the wire basket. Gently shake the container to remove all entrapped air. After the scale has stabilized, record the mass of the sample while immersed in water. We now want to place our sample in an oven and allow the sample to dry to a constant mass. Be sure that the oven has a temperature range of 110 degrees plus or minus 5 degrees Celsius. Once we remove our sample from the oven, we want to allow it to cool for 1 to 3 hours or until it's comfortable to handle. We now want to record the oven dry weight. Now that we've completed all the physical aspects of our test, we can go ahead and do our calculations for bulk specific gravity SSD, as well as our calculations for absorption. To do this, we'll need 3 weights: the weight of the oven dry specimen, the weight of the saturated surface dry specimen, and the weight of the specimen submerged in water. These are listed in our manual respectively as A, B, and C. And once again, all of our weights should be recorded in grams. So for our example, let's assume that the weight of our oven dry specimen is 2,958 grams, while the weight of our SSD specimen in air is 2,994 grams, and the weight of our submerged sample is 1,905 grams. The calculation for bulk specific gravity in the SSD condition is B divided by B minus C, or 2,994 grams divided by 2,994 grams minus 1,905 grams. And this should come out to 2,994 grams divided by 1,089 grams. And this should give us a bulk specific gravity SSD of 2.75. We can now go ahead and calculate our absorption. The calculation for absorption is B minus A divided by A times 100, or 2,994 minus 2,958 divided by 2,958 times 100. And if we go ahead and calculate this out, we should get 36 divided by 2,958, which should give us 0.012, and 0.012 times 100 gives us an absorption of 1.2%. This will conclude AASHTO T85 and ASTM C127 specific gravity and absorption of coarse aggregate. Listed here are the review steps for this procedure. And finally, there are 3 deviations worth noting between AASHTO and ASTM. They are listed here for your review.
Thank you, Mr. Kenneth Mariano, for the wonderful discussion of the test procedures. We will now move on to the next part of the discussion, which is the tabulation of data. And in this section, we will show you how we calculate the weight of the aggregate in saturated surface dry condition, oven dried condition, also the water absorption of the aggregate, and specific gravity and bulk specific gravity. So the first thing we need to calculate is the weight of the aggregate regarding saturated surface dry condition. And to calculate that, we need the weight of the container and the total weight of container and the aggregate together. So in this table, we have 3 sample types of aggregate. The first one is the G1, the second is round 3/4, and the third is crush 3/4. So in this table, we can see that the weight of the container is always 540 grams. So weight of container has a unit of grams, and we refer to this as weight number 1. And the total weight of the container in the aggregate is weight number 2. It is also measured in grams unit. So to calculate the weight of the aggregate
in saturated surface dry condition, we will now use the formula weight 3 is equals to weight 2 minus weight 1, which is weight 2 is equal to the total weight of container and aggregate, and weight 1 is the weight of container. So, using this formula, we can now use, in sample number 1, we can now use 5,750 minus 540 grams. The weight of the aggregate in sample number 1 is 5,210 grams. So, moving now to the sample number 2, using the same formula, we can now use 5,810 as the weight of container and the aggregate, and 540 for the weight of the container. So, we will now get the weight of the aggregate, which is equal to 5,270 grams. So, in sample number 3, we have the weight 2 as 5,940 and also 540 for the weight of the container. So, using the formula, we can now get 5,400 grams as the weight of the aggregate. So, moving on now to the oven dried condition, we have here also the weight of container as weight 1, weight of container and aggregate as weight 5, and weight of the aggregate as weight 6. So, for our sample number 1, we have weight 5 as 5,650 and weight 1 as 540, and using the formula weight 6 equal to weight 5 minus weight 1, we will now use, by substitution, we will get weight 6 equals to 5,650 minus 540. It is equal to 5,110 grams. Okay, so moving on to sample 2, using also the same formula, we can get 5,780 minus 540 is equal to 5,240 grams. So for sample 3, we get 5,720 minus 540. We will now get 5,180 grams. So, putting both of them together, we can now use those values to get the water absorption rate of our aggregate. So, here is the formula. We have water absorption is equal to weight 3, which is the weight of aggregate on surface dry condition, minus weight 6, which is the weight of aggregate in oven dried condition, all over the weight 6 times 100%. So, for our sample number 1, we will use 5,210 as the weight of aggregate in SSD, minus 5,110 as weight of aggregate in oven dried condition, all over 5,110 times 100%. We can get the water absorption of our sample number 1 as 1.95%. So, since we got the values of both weight of the aggregates in different conditions, by using both of them, we can get the water absorption rate of our aggregates. So, the formula for the water absorption is equal to weight 3 minus weight 6 all over weight 6 times 100%. So, again, using the values we get for our sample number 1, by putting it in the formula, we can get 5,210 minus 5,110 all over 5,110 times 100%. We can now get the water absorption of our sample number 1 as 1.95%. So now that we get our water absorption for sample number 1, what does it mean? So we have levels of strength of aggregates in terms of water absorption, and it is said that an aggregate must have a water absorption rate of below 2% in order for it to be strong enough or to be good enough to be used. So our sample number 1 has a 1.95% of water absorption, meaning it has a water absorption rate permissible to be used as our aggregate in construction. So moving on now to our sample number 2, we have 5,270 minus 5,240 all over 5,240 times 100%, it is equal now to 0.57%. So, as I've said earlier, 0.57% is below 2%, which is a level that is good enough for an aggregate to be used in construction. So, for our sample number 3, we have 5,400 minus 5,180 all over 5,180 times 100%, which is now equal to 4.24% water absorption. This water absorption rate is too high to be used as a construction material, meaning this material or this aggregate is so weak in terms of levels of water absorption it has. So after understanding how water absorption works and how we calculate it, we are now moving on to the specific gravity. So the specific gravity has a formula of specific gravity equals to weight 6 over weight 6 minus weight 4. So, calculating the specific gravity of our sample number 1, we have 5,110 as our weight 6 and 3,175 as our weight 4. So, by substituting those values to our formula, we have 5,110 all over 5,110 minus 3,175. We have now the specific gravity of our sample number 1 as 2.64. It is said that specific gravity has a normal level of 2.68. And as like I said earlier, specific gravity can be used to determine the strength of an aggregate, and it is also used to indicate if there might be a material contamination. So, as we can see, the specific gravity for our sample number 1, we now have 2.64, and the normal level for our specific gravity is 2.68. So we can see that the specific gravity of sample number 1 is a bit lower to the normal levels. So it might be this material might has some contamination and this might be weak. So moving on now to sample number 2, we have 5,240 as weight 6 and 3,390 as weight 4. So substituting, we have 5,240 all over 5,240 minus 3,390. We have now the specific gravity of 2.83. So we can see that 2.83 is almost at the normal level, but it is lower by a very small margin. So it is still an acceptable type of aggregate in terms of the specific gravity. So for sample number 3, we have 5,180 as weight 6 and 3,070 as weight 4. So by using the formula, we have 5,180 all over 5,180 minus 3,070. It is now equal to 2.45. And this material has a very low specific gravity. So it indicates that this aggregate is weak and it is very prone to material contamination. So for the last part of tabulation of data, we have the bulk specific gravity in saturated surface dry condition. So the formula for bulk specific gravity is weight 6 over weight 3 minus weight 4. So by using the formula, I forgot to mention earlier that weight 4 is the weight of the basket filled of aggregate under water surface. So that is weight 4. So we can get the value of weight 4 by measuring or by weighing our material and aggregate. So calculating now the bulk specific gravity for sample number 1, we have 5,110 as our weight 6, 5,210 as weight 3, and 3,175 as weight 4. And by putting it in the formula, we have 5,110 all over 5,210 minus 3,175. We will now get the bulk specific gravity of our sample number 1, which is 2.511. So, moving on now to our sample 2, by using the same formula, we can get 5,240 all over 5,270 minus 3,890. The specific gravity for sample number 2 is 2.787. So, moving on to our sample 3, we have 5,180 all over 5,400 minus 3,070. And the specific gravity now for our sample number 3 is 2.223. So, that's it for the discussion regarding specific gravity, water absorption, and the weights of aggregate. So, thank you for listening, and I hope you learned something.